Hello and welcome to FU Cancer Mike's Journey. This is episode number 9. Today I want to talk about basically the different characteristics between a normal cell and a cancer cell. So we talked about starving the cell for sugar because one of the differences is that cancer cells can't consume fat and survive as a food source. So there's a few other things that are obviously different characteristics of cancer cells, but it's going to take you back to when I was first diagnosed with colorectal cancer. They said you have cancer and you've got this tumor that's the size of an orange. So, I'm an electrician. I don't know what that means. That means I've got something invasion the size of an orange somewhere in my colon, but what does that actually mean? So today, I just want to kind of go over some basic things to lay the foundation for what I want to talk about in future episodes. But it's going to say, okay, here's what your normal cell makeup would be. Something like that. So you've got a number of cells here. They're all nicely shaped. They're bound together. They stay within the compounds of where they're supposed to be. So that's what a normal cell does. And the other thing a normal cell does is if one cell were to die off for any reason, there's another one that takes its place. And that's it. And then that cell rehabilitation or regeneration stops. In a cancer cell, like the one in my colon, so say this is your same surface, and these are the cells, these are the cancer cells. So cancer cells are not uniform. They regenerate in different shapes, different sizes, different makeup. They're not bound together, so they don't have that nice uniform positioning. They just divide and grow on each other and expand on each other, which is why you get those tumors that have actually grown because of the compounding of these cells on top of each other. The other different thing about cancer cells is that they don't fully mature before they divide. So in a normal cell, this cell would be 100% mature. It actually spends 80% of its time just conveying information. The cells hold the DNA, talk to the other cells in the area. These guys, their DNA is messed up. It's mutated. Some of it's missing. So they don't have any of the stops in place that a normal cell would, and they just grow and grow and grow. Another interesting characteristic is when they said to me, well, 8 years later, you have cancer again, you have colon cancer in your bone. It's basically what they said. It was, well, my colon and my bone that we're talking about, they're not really that close together. They don't touch each other. Or the colon's not even there anymore. So what does that mean? In a normal cell, if this cell here tried to migrate out for whatever reason, if the protein that holds them together let go and it tried to go somewhere else, it would automatically commit suicide. There's a protein in there that says, you don't belong outside of our little world. If you're going to stray off, then you need to self-destruct. And that's what it does. That's normal. For cancer cells, if this cancer cell here wants to go and it comes unbound and floats away. Well, the DNA for that cell could very well and most likely is not in its full form, and it doesn't know that it's supposed to self-destruct, so it just goes and moves on and finds somewhere else to live, really. The other thing that's important about that is that when you're throwing chemotherapy at various cells and radiation, there's radiation. What can happen is you can actually dislodge these cells, and then they are able to flow out a bit. So that's a calculated risk. But when you take radiation, you also get chemotherapy, and the chemotherapy is supposed to come in and destroy all these cells. But these cells, they're super energy hungry, and they divide all the time. They're constantly just splitting up. So what is possible is that they can become immune, or at least resistant to the chemotherapy that you're trying to use to kill them. So there's there's an identifier for this. This is the next obstacle that I'm going to try to explain, how to actually stop these mutations outside of starving the cancer, stop these mutations, what actually causes it, and also how to teach the immune system to identify these guys and hopefully help rid them. Okay, well, that's it for today. Thank you.